So good morning to all of you. Now we'll go for the second type of data network, that is a wireless data network. So in that we have to study wireless LAN, Wi-Fi, then WiMAX, Bluetooth, then ZigBee, infrared, ultra wideband, satellite, and microwave. So what is actually wireless LAN? Wireless LAN, also called as a WLAN, are the local area wireless networks that adheres to the IEEE 802.11 set of standards. It can operate at different frequency ranges and support different message transfer rate. This standard 802.11 works in the 2.4 gigahertz frequency. So it is using 2.4 gigahertz. Then it also operates to the maximum raw data rate of 54 Mbps. The WLAN network consists of computers with WLAN card, that wireless LAN cards are there, connected to the WLAN access nodes that have the wire connection to the internet. Then second is the WiMAX, the worldwide interoperability for microwave access from the WiMAX forum is proposed as a wireless wide area broadband access technology based upon the IEEE 802.16 standard, typically offering 10 Mbps over the 10 kilometers along the speed of 20 Mbps are achievable over 10 km, 10 kilometers. The IEEE 802.11 and 802.16 technologies are distinguished by the type of medium access control, that is a MAC, whereas 802.11 MAC uses CSMA before talk and it is a connectionless. The 802.16 MAC support full quality of service, bandwidth on demand, is connection oriented. It supports centralized control and scheduling and offers multimedia support. So multimedia is also supported by WiMAX. Then the third one, commonly known, everyone use this, that is a Bluetooth. Bluetooth 11 is a standard for short range wireless communication. Depending on the class of device and power, Bluetooth application include both local communication and increasingly local control. Unlike infrared, Bluetooth does not require a line of sight between the transmitter and receiver. Current popular Bluetooth devices and the application includes hand-free mobile phone handsets and a car case to support hand-free communication when driving and wireless control of the game console. So these are where we are using this Bluetooth. Bluetooth uses the same radio frequencies as wireless LAN but with higher power consumption, resulting in the stronger connection. Wireless LAN requires more setup. It uses access nodes and is better suited for operating full-scale network because it enables a faster connection, a better range from the base station, and better security than Bluetooth. Unlike wireless LAN, Bluetooth does not require much configuration to set up shared resource, transmit files, or to the set of audio links. For example, headsets and hand-free devices. Then the next one is your wireless network is your ZigBee. ZigBee is a specification for suite of communication protocol from the ZigBee Alliance formed in 2002. It uses small, low-power digital radio based on the IEEE 802.15.4 standards for wireless personal area network. It is a technique in which a node continuously transmits small packet to advertise its presence to the other mobile units. ZigBee protocols are intended for use in embedded applications requiring low power rates and low power consumption and low latency. This protocol used for industrial control, embedded sensing, medical data collection are the example where we are using the ZigBee. There are three different types of ZigBee devices. First one is a ZigBee coordinator, that is your ZC. The root of network tree is formed by ZigBee coordinators and can bridge to other networks. by using the ZigBee coordinate. Then second one is a ZigBee router, ZR. It acts as an intermediate router passing data from other devices. Then third one is a ZigBee end device. It have talk with parent node. Important functionality is given through ZN devices. Then fourth one is a infrared. IR is a short range, low bandwidth data consumption communication used to communicate between computers and between the computer peripherals. Remote controls and infrared data association devices use infrared light emitting diode, that is a LEDs, to emit infrared radiation which is focused by a plastic lens into the narrow beam. A beam is modulated, that is switched on and off to encode the data. The receiver uses a silicon photodiode to convert the infrared radiation to an electrical current. It responds only to the rapidly pulsing signals created by the transmitters and filters out slowly, changing infrared radiation from the ambient light. Then next one is ultra wideband, that is your UWB, is a technology for transmitting information at data rates exceeding 100 meters bits per second spread over large bandwidth more than 500 megahertz at the low power range over short distance. The FCC has authorized the unlicensed use of UWB, that is your ultra wideband, in the 3.1106 gigahertz frequency range. In contrast to the conventional wireless system that needs to use baseband signal to modulate radio frequency carrier signal, RF carrier signals, ultra wide bands can be used directly to transmit signals at the baseband frequencies. In pulse-based UWB, the transmitter only needs to operate during the pulse transmission, producing a strong duty cycle on the radio and minimizing the baseline power consumption. Then the last one is a satellite and microwave communication. Satellite communication has the potential for truly ubiquitous global communication. Commercially, satellites use part of microwave range frequency for transmission. Geostationary satellites have the advantage of much simpler antenna design and configuration, and relatively small number of these satellites can be interlinked to provide the global coverage. In the 2000, the major use of satellite communication is used for wide area TV video broadcasting, although it has also been challenged by the cable network. An important use of satellite communication is to serve many large number of thin routes which cannot economically be served by the cable. Then the third type of network you have to study is your audio networks. So audio networks were the first type of pervasive communication network. So all of you know that audio network is a first example. We are using the pervasive communication. There are two types of audio networks. First one is audio unicast network, that is your PSTN, and second one is audio broadcast, that is your radio network. These are the two types of audio network. Now PSTN, public switching telephone network, that is nothing but your voice network. So public switching telephone networks are designed to support voice communication. Used to support voice. Actually, two people are speaking to one another. So what they are transferring the voice. It uses analog transmission, but this can be replaced by digital transmission. Many telephone workspace use separate networks for voice and data, although there is a progression towards combined voice data and audio video networks. Telephones act as an access device to the PSTN and are typically connected to the private circuit switch network or private branch exchange. Individual home user tends to be connected to the PSTN using the single line local loop to the local switching station. The PSTN can also be accessed using fixed or mobile phones. Many users also use the PSTN as an access network to the data exchange network, that is using the internet. The PSTN use circuit switching. So circuit switching method is used to interlink different network links to form an end-to-end connection. Network links were used exhaustively by pairs of callers when they are online. The PSTN will be designed to be very resilient. The circuit switching used in telecom networks typically uses the hierarchical above 5 levels of switching offices that handles particular number of ranges. Then intelligence network, earliest type of digital telecommunication networks were designed to support specific services, use specialized logic contains in the specialized switching network element, and network features are or services proposed have to be added and implemented directly in a core switch system, which lead to very long introduction times for the new services. The intelligence for networks service model standardized by the UTUI enables telcos to offer new value-added and customized voice services such as toll-free calls. That is example is a 0800 numbers. This supports independent component-based services in general purpose computer nodes rather in the special switching nodes. This enables service provider to drive new services rather than the network provider.